All right, y'all, welcome back. Today we're going to talk about topic for day 3. This will be the last day in this unit. All right, so it's really short, only 3 days. And today we're going to talk about how to graph quadratic inequalities. All right, so we did linear inequalities, we did absolute value inequalities. Today we're going to talk about quadratic inequalities. All right, so there's a few steps up here. All right, so the first thing we need to do is find the zeros. So basically we're going to factor, okay, and these are called our critical numbers. Once we find our critical numbers, we're going to put them on a number line so we can see our test intervals, which you'll see in just a second, and then evaluate a number in each interval to determine whether it gives you positive or negative for that part. And then the fourth step is to list your solution. Okay, it'll make a little bit more sense once we do a problem. Okay, so this question, all right, here's what we need to do first. 2x squared plus 5x is greater than 12. What we need to do first is figure out what the zeros are. All right, so this, in order for us to figure out the zeros, we have to factor it. Okay, since this is a quadratic, we can factor. And in order to factor, it has to equal 0 first. So my first step is to make sure that my problem equals 0. So I would subtract the 12 from both sides. Okay, now it doesn't exactly equal, it's greater than 0. I made this side equal 0. Okay, and it says where is, what are we looking for? Like, what is this asking us to find? Notice that the x's are on the greater than side of the inequality. Okay, so greater than 0 means it is above the x-axis, right? Anything bigger than 0 means it's above the x-axis. So that's what we're looking for. Where is the graph above x-axis? Okay, that's what it's asking us to find. So if the x's are on the greater than side, we're looking for above the x-axis. And now we need to find these critical numbers. So to do that, we're going to have to factor this, okay, which is what we did last semester, which you did in Algebra 1, Algebra 2. To factor, you multiply the first times the last. So that would give us negative 24. And then the middle number goes on bottom. So what multiplies to get negative 24 adds to get 5. That would be 8 and negative 3. So remember, we put those in parentheses, 2x plus 8. Whatever comes first, we put first. 2x minus 3. And then we could divide this one by 2 because they both have a 2 in common. So x plus 4 and 2x minus 3, right? We're trying to find the 0. So I don't need to worry about this inequality quite yet. So I just made it an equal sign, all right? And then to find the zeros, we set each one equal to 0. And we solve them, okay? Again, this is what we did last semester and what you did in your other math classes. So we would subtract 4, negative 4. We would add the 3 and then divide by 2. 3 halves. So I now have what I call the critical numbers. Okay, so the critical numbers are negative 4 and 3 halves. 3 halves is the same as 1.5. All right, so now that I have found those critical numbers, I'm going to put those two numbers on this number line. So negative 4 will go here, and let's say 3 halves goes here. Okay, so negative 4 and 3 halves. So now you notice I have 3 pieces on this number line. I have this piece right here, I have this piece in the middle, and I have this piece on the right. Okay, what I need to do is figure out in each interval whether it's positive or negative, because I'm trying to find where it's positive, right, where it's above the x-axis. So I need to know which part is positive, which part is negative. Okay, I will tell you, you can pick any number you want, but I always start with 0. Right? So figure out where 0 is going to fall in this interval. 0 is going to fall somewhere in the middle, right? And I always put it in a square, so I know that's the one that I picked. So 0 falls in the middle. I'm going to take this 0 and I'm going to plug it into this problem. Okay, if I plugged 0 in for x, right? Let's say I plug 0 in there. I would have 2 times 0 squared plus 5 times 0 minus 12 is greater than 0, right? So if I solve this, I would get negative 12, correct? Because 0 plus 0 minus 12 is negative 12. So that gave me a negative answer, all right? So I'm going to put a big negative sign in there, okay? I'm going to put a big negative sign in there. So that's the middle. Now I have to test these other ones. So now I need to pick another number over in this interval. If this is 1.5, let's just say I pick 2, because 2 is bigger than 1.5. And now I have to plug this 2 into this and see what I get. So if we did that, 2 times 2 squared plus 5 times 2 minus 12. And if I solve this, 2 squared is 4. 4 times 2 is 8. 5 times 2 is 10 minus 12. So I get 18 minus 12, which is 6. So I now know that this side is positive. Okay? So I know this one's negative, this one's positive. Now I give you a little shortcut. 95% of the time, it's going to alternate between them. Okay, so it's going to be positive, negative. That would make this one positive. Okay, most of the time. Okay, I would still check it, but most of the time it is going to alternate. So if we wanted to check this one, let's say we did, let's say I plugged in -5 over here, right? Because -5 would fall in this interval. Again, pick any numbers you want, but pick smaller numbers so they're easy to work with. And then let's test -5. So I'm going to put -5 in here. So that would be 2 times -5 squared plus 5 times -5 minus 12. And if I were to simplify this, -5 squared is 25 times 2 is 50. 5 times -5 is minus 25 minus 12. 50 minus 25 is 25 minus 12. 25 minus 12 is positive 13. So this one is going to be positive. Okay, so now I see this part of the graph would be positive, this part would be negative, this part would be positive. And by positive and negative, I mean above or below the x-axis. Okay, so that means that the answer to my problem, because I want it above the x-axis, right? I want to know where it's positive. So above means positive, so that means it would be this interval. So from -infinity, because this keeps going forever, from -infinity until -4. And so this u means also like included and this piece from 3/2 to positive infinity would be my answer to this question. Okay, and I'm going to show you what this looks like on a graph, okay, so that you'll have an idea. All right, so that is the answer to this problem right here. Okay, so if we go to Desmos, right, if you guys are familiar with Desmos, and we type in that problem, all right, so it's 2x squared plus 5x minus 12, so plus 5x minus 12, and you look at this graph, all right, we want to know where it's above the x-axis, so that's this entire piece. So from -infinity way over here until I get to -4, it's above. Then it goes below, 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 until I get to 1.5. Once I get to 1.5, it then is above the x-axis again. So that's how I know that my answer is correct, because from -infinity to -4 and from 3/2 to infinity, it was above the x-axis. Okay, and again, above the x-axis means positive. All right, so this part is just kind of our check to see whether it's positive, negative, or positive. Okay, you can probably do most of that in your head. All right, so you might not have to write that step down. Okay, we're gonna do one more problem that is a little bit more difficult because these take a little while. Okay, so the next one looks like this. So here's our next problem. So again, this doesn't equal 0 yet. Okay, so I need to make it equal 0. So I'm going to add that 48. Everything else is going to stay exactly the same. Plus 48 less than or equal to 0. Okay, so now think about what we're trying to find. Now look at where the x's are. They are less than 0, right? The x's are on the less than side. So I want to know where this graph is below x-axis. Okay, or another way to think of it is, where is the graph negative? Okay, so below the x-axis means where's the graph going to be negative? All right, that's going to help us with our number line. So we need to factor this first. Okay, now there's 4 terms. So if you remember back from last semester in Algebra 1, 4 terms, we group them. I'm going to group the first 2 together and the last 2 together. And I look for what they have in common. These 2 have an x squared in common. If I took out an x squared, it would leave 2x minus 3. These 2 have a negative 16 in common. So I'm going to take out negative 16, and that would leave 2x minus 3. Right? So I know I'm correct because these match. Right? I want them to match. So then I take the 2 on the outside and put them together, x squared minus 16, and then I keep the 2x minus 3 the same, and it equals 0. Because remember, we're not worried about that inequality until the end. All right? Now I could still go a little bit further because this part, they are difference of squares. So x minus 4, x plus 4, and then the 2x minus 3 has stayed exactly the same. So now I factored it. Now I take each one of those and set them equal to 0. Because these are going to give me my critical numbers. All right? So x equals 4 is one answer. X equals negative 4 is another answer. Then I would add 3, divide by 2. 3 halves again. It's not always going to be 3 halves. Don't think that part of it. Okay? So now I have 3 numbers that I am going to put on my interval. Okay, so I have 3 things that will fit in there. So my first one is negative 4, then 3 halves, then 4. So I'm going to put negative 4, then I'm going to put 3 halves, then I'm going to put 4. They have to go in order. Make sure you put them in the right order. 3 halves is the same as 1 1/2. And now I have more intervals to check. I have 1, 2, 3, 4 pieces that I have to check. But I always do 0 first because 0 is the easiest one. So 0 is going to fall in here. 0 falls right there. If I were to plug 0 into this problem, right, let's just say I plug 0 in. It would give me 2 times 0 cubed minus 3 times 0 squared minus 32 times 0 plus 48. If I plug 0 in, this becomes 0, this becomes 0, this becomes 0. So I'm left with positive 48. So that means this entire interval is positive. Okay, the whole thing is positive. And again, once you figure out 1, it should alternate. So that means this one should be negative, this interval should be negative, and this should be positive. So it should go negative, positive, negative, positive. Okay? It should alternate between them. All right? So that's just a little bit of a shortcut. It should, as long as you get the first one right, they should alternate. If you mess up this one, then you're kind of in trouble. All right? So it might benefit you to check some other ones along the way. All right? So I forgot to write my critical numbers right here. Sorry about that. Negative 4, 3 halves, and 4. Okay. So now we have our number line, right? We have what it looks like. And now we think about what's this asking us to find. It asked us where is it below the x-axis, which means negative. So that means we only want the part that is negative. So that is this part here and this part right here. This is the only 2 pieces that are negative, right? This piece and this piece, because here it was positive and here it was positive. So my answer to this question is this one goes this way forever, right? It never stops. So from negative infinity to negative 4. Now you will also notice this inequality has a line under it. It's equal to. So that means we have to put a bracket around the negative 4. Okay, so the equal sign means we put a bracket. On the first one we did, there was no line under this. So notice that they're all parentheses. Okay, if there's an equal sign under it, you put a bracket. So that's part of the answer. Then the other answer is we also have this piece, 3 halves with a bracket to 4 with a bracket. Okay, and let me just show you what this graph is going to look like real quick. If we were to graph this thing on Desmos, so that's our final answer right there. But if we were to graph this on Desmos, we would get 2x to the third, 2x raised to the third, minus 3x squared, minus 32x plus 48. And look at this graph, right? It's really big. right? And it just kind of keeps going and going and going and going and going. We wanted to know where the graph was below the axis, right? So that's this piece here. So from negative infinity, way down here, right, way over here, negative infinity until we got to negative 4. Then the graph was above the x-axis, and it stayed above, and it stayed above, 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 until we got to here, 1.5. Then at 1.5, it was below, 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 until we got to 4. Once we got to 4, the graph was then above the x-axis. So that's how we determined that this was our answer. Okay? So that is how you solve quadratic inequalities by factoring, find the critical numbers, graph it on the number line. Okay? If you have any questions, please reach out to me. Please let me know. Thank you.